Hey guys, Miss Subin here, and today we're going to be comparing and ordering rational and irrational numbers. So for our objective, we're going to compare two real numbers today using greater than, less than, or equal to symbols. We will compare several real numbers and place them on a number line in the correct order. So first thing we're going to think about, can we compare these numbers as they are written? Well, at first glance, I would find this very difficult, and I have a math degree, and I find this very difficult to compare at first glance because 2.7 is written as a decimal, 10 over 4 is written as a fraction, and the square root of 7 is written as a square root. So right now it's really hard to tell which number is the biggest because it's tempting to say that 10 over 4 is the biggest because 10 is the biggest number. But 10 over 4 does not have a value of 10. It has a different value. So how I like to approach these problems is instead of trying to put these in order just by how they are, I like to rewrite their values. Since they're all in different formats, the first one's a decimal, the middle one's a fraction, and the last one's a square root, we're going to convert each one into a decimal so that way they're all the same format and they're easy to compare. So let's give this a try. So the symbols we're going to be using today, just a reminder in case you forget. First we have our less than symbol, and I remember this one's less than because L goes the same direction as our symbol. We also have our greater than symbol, which is the other way around. And then finally we have our equal to, which is only used when they have the exact same value. So here's an example. We're going to compare these two real numbers using greater than, less than, or equal to. So we have 11 halves and we have 5.1. So right now, this is hard to tell if they have different values or which one's bigger because they're not in the same format. So since they're not in the same format, we're going to make them the same. And the general rule, the easiest and fastest way to do this is to convert everything into decimals. So right away, I notice that we already have a decimal here. And that's what we want. So 5.1 is already done because it's written as a decimal. However, we have a fraction here, which we do not want. So we're going to have to change this into a decimal. Now, fortunately today, we do get to use our calculators. So if you have your calculator, get that handy. We're going to convert 11 halves into a decimal with the same value. We can do that by doing numerator divided by denominator. When I do 11 divided by 2, I get a value of 5.5. So that means that we can kind of get rid of this 11 halves and just think of that as 5.5. So now we just have to compare 5.5 with 5.1. Since they both have the same whole number, we both know that they're around 5. So we have to decide if 5.5 or 5.1 is larger. So I'm going to look at my tenths place and decide which one has a bigger value, since they tied in the whole number. Well, 5 is bigger than 1, so I'm going to use my greater than symbol because 5.5 is the larger of the two. So what we did here is we kind of rewrote our problem so that both sides were decimals so it was easier to evaluate. Let's go ahead and try another problem. All right, so here's our first problem. We're comparing 4.0 with 16 over 4. So we're going to follow the same process here. .0 is already a decimal, which is what we want, so we don't have to do anything else for this problem, or for that side of the problem. But here we have a fraction. That's not what we want. We're going to have to convert that one. So just wherever I have space, I'm going to convert 16 over 4 into its decimal. I'm going to do that by doing 16 divided by 4. For every fraction, it's numerator divided by denominator. It does not matter which number is bigger, it matters which number comes first. The numerator is always first. When I do 16 divided by 4, I get the whole number 4. So what we can kind of do here is we can forget this 16 over 4 because 16 over 4 had the same value as the whole number 4. So now we just have to decide, is 4.0 or 4 larger? Turns out for this problem, 4.0 and 4 have the same value, so we're going to use an equal sign here. All right, let's see if we're getting the hang of it. Let's do another one together. Uh-oh, we have a little bit of a harder problem here. We have a square root we have to deal with. The procedure remains the same. If you see a decimal, you do not need to convert it. It's fine how it is. But if you see a square root, we need to estimate using our model. So over here, I'm going to recalculate my square root of 14 using my box method we learned last time, or last week. So square root of 14, it is not a perfect square, so we're going to have to get a decimal approximation here. So the closest square without going over, I can use 3 times 3, which is 9. 4 times 4 is 16, that's too big. So I'm going to start by drawing a 3 by 3 square here. And I am going to do this example very quickly because today you should already know how to do these. And this is why I told you it was important for you to know how to do these, because we're going to be using them. So 3 times 3 equals 9, which is the closest perfect square to 14. So 3 is going to be our whole number on our estimate. Now, what we need to do is make our model a little bit taller and a little bit wider so that we can write a fraction to go with our whole number of 3. All right. Total new space is 1, 2, 3, 4, 5, 6, 7. To get from 9 to 14, I'll need 10, 11, 12, 13, 14. 1, 2, 3, 4, 5 check marks out of the 7 we could have used. So our approximation here is the whole number 3, and then using my calculator, 5 divided by 7, I get a really crazy number, but because we're estimating, we get to just write one number after the decimal. So that means that the square root of 14 is about 3.7. So now what I'm going to do is go back to my original problem where we're comparing the square root of 14 and 2.9. And I'm going to kind of forget square root of 14 and instead use our estimate 3.7 to compare to 2.9. Well, 3 point something is always going to be bigger than 2 point something. So 3.7 is our bigger value. So I'm going to use a greater than symbol. So now this reads 3.7 is greater than 2.9. Which means that our square root of 14 is greater than 2.9. All right, one last example. Now, unfortunately, in this last example, neither one here is a decimal, so we're going to have to convert both of these. I'm going to start with a fraction. I'm going to convert that by keeping my whole number the same and then using my calculator to do numerator divided by denominator. So 1 divided by 2 gives me a 0.5. Just don't forget your whole number does not come from your calculator. The whole number comes from the original value. So 4 1/2 has the same value as 4.5. Then we have a square root, which we have to estimate using a model. So square root of 15 we're going to do over here on the side. We're going to estimate that to give us a decimal approximation, which means a really good guess. It won't be exact because we're only estimating. All right, 15, again, we're going to use a 3 by 3 square because 4 by 4 would be 16, which is too big. 3 times 3 gives me 9. So our whole number is going to be 3 on our approximation. Then we're going to have a decimal in there. To get my fraction or to get my part after the 3, we're going to make our model a little taller and a little bit wider. Starting at 9, let's see how many spaces we could use. We have 1, 2, 3, 4, 5, 6, 7 we could use. Starting at 9, I'm going to count to 15 and see how many we need to get to 15. So 9, 10, 11, 12, 13, 14, 15. We needed 1, 2, 3, 4, 5, 6 out of our 7 pieces. Let's rewrite this as a decimal so we can use it to compare in our original work. In my calculator, I'm going to do numerator divided by denominator. So 6 divided by 7. And I'm going to estimate the value by just using the value in the tenths place, which here is 8. So the square root of 15 is approximately 3.8 according to our model. It's not the exact value, but it's pretty close. So the square root of 15 we can rewrite as 3.8, and 4 1/2 we can write as 4.5. Remember, we have not changed any values, we just changed how they were written. Now when we compare square root of 15 and 4 1/2, we can instead compare 3.8 and 4.5. Between those two, 4.5 is our larger value. So I'm going to say 3.8 is less than 4.5, which means that square root of 15 is going to be less than 4 1/2. Good luck today.